Okay, this will be part 2. We'll cover problems 18 and probably 21 on this video. Once again, we jump back in here and we know that we're looking for the minimum, the maximum values on this interval of the function x to the 3/5. And once again, a little bit of, this is from the previous one, a little bit of exploration can help us actually get this answer ahead of time. X to the 1/5 power would look similar to a square root graph, except we can do odd roots of negative, so it should look something like this. And then we're cubing that, which is going to make these bigger, but the general shape won't change. So what that means is, once again, I think I already know my answer. Pay very close attention that on number 18, the left side at -2 is not included, but it would be clear that if we were including -2, that would be the smallest, but it's an open hole on this side. And at x equals 3, we're going to be up here, and so I think I already know that my maximum is going to be whatever. Let's see if we plug in 3, so maximum is going to be x, I'm sorry, not x, 3 to the 3/5 power. Whatever value that is, and that's going to occur at x equals 3, and my minimum is going to be none. Okay, so let's see if we can get the math to back up what we already know to be the answers. Alright, so once again, I already know I'm going to check my endpoints. And so that means I'm going to check simply f of 3 this go around, which would again be 3 to the 3/5. -2, no endpoint, and so that's it. So now I'm going to look for critical values. And so that means I'm looking for the derivative of f, which would be 3/5 x to the 3/5 minus 5/5 would be -2/5, which simplified would simply be 3 over 5 x to the 2/5. And now I want to know when is the derivative equal to 0, to look for that slope of 0. And when I set this equal to 0, I quickly see, hopefully see, that there is no way that the derivative can equal 0. We have a fraction. The only way a fraction can equal 0 is if the numerator equals 0. Or you could just algebraically solve it, and when I multiply by the denominator to try and get rid of my fraction, I end up with 0 equals 3. So we asked the math a question. We said, when is the derivative equal to 0? And the math tried to answer it, but we ended up getting gibberish because, as we already know, there is no place where the derivative equals 0. So that is out, but we also need to consider the other part of the critical values, and that is, when is the derivative undefined? And this time, again, if I take a close look at the derivative, I see that as a function, we know it's going to be undefined whenever the denominator equals 0, because I can't divide by 0. We also have a root here. It's the 5th power, so I can do roots of any numbers, so that doesn't matter. So really, again, all I'm considering is when is the denominator equal 0, and that's going to happen when the bottom is 0. So when is it undefined? At x equals 0. So then we come back here, and now I know I also need to find what f of 0 is, because that got flagged as a possible critical value. And I plug in 0 and I get 0. Okay. So now we come to a little dilemma. If I don't know what the picture looks like, and all I have is this to consider, then I might be mistaken and think that the maximum is 3 and 3 to the 3/5 and that the minimum is 0. Because I can't check the endpoint, these are the only two to check. 0 is clearly a smaller number than this, minimum and maximum. And as we know already, because we know the graph, we would be wrong. So the question is, what math should we do to not fall into that trap? And I think the best answer to that question is, if you're not doing endpoints, is to consider the limits as we approach the endpoints or as we approach infinity, if it was an unbounded function. So we already know what the limit is as we approach the right side. It's the value at the right side, so we don't need to check that. But since we really didn't explore what was happening on the left side of this graph, I really think it's necessary for us to take a look at the limit as x goes to -2 to see what we get there. And so when I do that, again, I know how to take limits. I just plug in the number. So I know that the limit is simply going to be -2 to the 3/5. And a negative number cubed is negative to the fifth root is negative. So I don't know what the value is, but I know it's a negative number. And so with that, it kind of lets me know that f of 0 equals 0 is not a minimum or a maximum. It's just a value in between. And so based on that, hopefully I would come to this same conclusion. You can see how knowing what the picture of the graph looks like makes this, a very easy process. One other thing that would have possibly given us that same conclusion, that it wasn't a minimum value, would be if we looked at the sign chart. So I know we're getting a little messy in here, but let's just jump right over here and look at a sign chart. And again, when we're talking about a sign chart, we're talking about analyzing just the signs of the derivative, keeping in mind that the derivative is just slopes, and so the sign lets us know if we're increasing or decreasing, if the slope is positive, or increasing if the slope is negative, or decreasing. So what we want to do on a sign chart is we want to put all of the relevant points on here. So in this case, at x equals 0, we identified it as a critical value. That was the only one, but since this is a limited domain, we might as well stick the endpoints on here as well. Okay, so let's figure out what my slopes are as we go from 0 towards 3. I know that they won't change. I know that they have to be whatever the value is at 0.1, the slope value, it's going to be the same at 2.999. I know it never changes from positive to negative or negative to positive in that range, because in order to do so, we'd have to have a slope of 0 or some other undefined, and we didn't find any values there. So what that means is I can pick whatever value I want between 0 and 3 and plug it into my derivative, and whatever I get is what they all are. Alright, so my derivative is, again, this function here. Let's just rewrite it. And those of you waiting to look at number 21, we're going to do that in the next video, because this is going long. So looking at the derivative, I get 3 over 5 x to the 2/5. So if I plug in, say, 1, I get a positive number divided by a positive number, which is positive. So what that tells me, again, we already knew that looking at the graph, that the slope was positive. So what we know so far is that the derivative is undefined at 0. And according to my picture, it shouldn't be, which kind of tells me my picture is not 100% accurate. And we'll come to the conclusion of what's happening at 0 in just a second. So now let's plug in a number to the left of 0, like -1. The top is still positive, it's 3. The bottom is a negative number squared, makes it a positive number, because this is the 2/5 power. And then we take the 5th root of a positive number, and we get a positive number. So we have a positive divided by a positive, which tells me that as I was approaching 0, my slopes were positive. so they're positive, and then for some reason my slope at 0 is undefined, and then my slopes were positive as I left 0. So in other words, what happened is we hit a vertical tangent right here. So my graph is a little bit off, but our slopes were positive, undefined, and then still positive afterward. And so what that means is not even a local min or maximum. What we have here is just a vertical tangent line. So it's not a cusp or a corner, which would generally lead to at least a local min or maximum. So if that's the case, we were wondering, hey, is this value at 0 a minimum? When we were doing the math, we checked it over here and we got 0, lower than anything else we knew. But looking at the signs, we know that the slope is positive as we head up to that. The only way that that would even be possible is if we clearly had values that were less than 0, so that our positive slope moved us up to 0. I'm not sure if that's 100% clear to everyone. You might want to go back and listen to this again and just try and figure it out, and or ask me in class. But long story short, there's a lot of evidence here that leads us to our conclusion of no minimum, but I understand that it's difficult maybe to think of which evidence is necessary. Okay, so at 11.5 minutes, we're going to stop this video, and we'll pick it up in part 3 with the next section.